All right, folks. The evil kid, Bad Jimmy, I guess, is still at the top of the Center for the Sciences. This time around, instead of dropping a rock from the top of the building, he's going to lean over the edge and throw a rock straight up. He throws the rock straight up with a speed of 12 meters per second. Um, and the first question I want to answer here is, well, how high does the rock go? What height does the rock reach above his hand? And then I guess how high would that be above the ground? Um, there are some additional questions that we'll answer about this situation um, in a different video, but I want to focus on just this one problem in this one. Okay, so let's take a look here real quick. I'm going to try to draw a little sketch. There we go. There's Jimmy. Ball right there, and then the ball travels upwards some distance there. Let's see. Let's put the ground in here. Let's see. The distance here is 30 meters. Let's see. So there's a little sketch. And what I really want to know is I want to know what this distance is right here. Now, in order to answer that question, I'm going to compare kind of the ball's initial position at the start of this problem, which is right there at the moment when it leaves Jimmy's hand, to its position kind of at the end of the time period that I'm concerned about for right now, which is how high it gets above Jimmy and also above the ground. All right, so there's my question. I'm really interested in maybe what is the ball's displacement? Y right there. All right, so given this information or given this sketch, we can now move on to our next step in our problem solving process, which is making a table of variables, a table of our kinematic variables. So let me give us a fresh page to start off with. There we go. And now let's list out those variables. I want to know what y is. I don't know what it is. My initial velocity is 12 meters per second. Let's see, I've got final velocity, I've got acceleration, I've got time. All right. I definitely do not know the time. The acceleration, once the ball leaves Jimmy's hand, the only thing that's acting on it is gravity. Gravity always has an acceleration of negative 9.8 meters per second squared. So negative 9.8 meters per second squared. That's assuming we make upwards the positive direction, which we're going to stick with that idea. All right. So we don't know the displacement. We don't know the time. We know the initial velocity is 12 meters per second. We know the acceleration is negative 9.8 meters per second squared. I need 3 of 5 things in order to kind of apply my kinematic equations and make the whole process work. The only thing I haven't filled in yet is the final velocity. All right. So we're thinking about, let's see, the velocity of this ball or this rock, which is when it reaches the apex of its flight, when it reaches the top of its flight. The velocity at the top of the flight in the y direction is 0. The rock goes from having an upwards positive velocity to having a downwards negative velocity. And when it does that, it's changing signs. It's got to go through a value of 0 meters per second. So that's its velocity at the apex. Looking at our equations, the one that makes the most sense to use probably is this one. V squared is equal to V naught squared plus 2ay. Let's rearrange that and solve for y. We're going to divide both sides by 2a. And now we have an expression for y. The final velocity is 0. The initial velocity is 12 meters per second. I'm going to drop the units again just so that I have a little bit less writing to do. There we go. And when I do the math here, I get in the numerator negative 144. In the denominator, it's negative 19.6. I've got a negative divided by a negative. That gives me a positive value. And I see there that the displacement for the ball or for the rock from the moment it leaves Jimmy's hand to the moment it reaches its apex is 7.3 meters. All right, so that's its displacement. If the question had asked maybe something like, what is its height above ground? Then I would just want to add the initial height, the initial height of 30 meters to that displacement. And so I could say that the height above ground is 37.3 meters. All right, so it just depends on maybe what we were asked for in terms of the problem. If we were doing like a formal homework problem or a test problem, something like that, what was the exact phrasing? Displacement was 7.3 meters. Height above the ground was 37.3 meters.